Hello students, how are you all? I hope that you all are good. As we know, the series of units and measurements is going on and successfully we are finished the two lectures. In a first lecture, we are discussed about physical quantities and the type of physical quantities. In a second lecture, we are discussed about dimensional analysis. What are the dimensional symbols of fundamental physical quantities and how to write the dimensional formulas of given physical quantity. And finally, in that lecture, we are discussed about conversion factor. So, and all these things that we are discussed in a previous session. And this is the third lecture of units and measurements. Okay. So, in this session that we are going to discuss about principle of homogeneity of dimensions. So, this is one of the important lecture and we have some previous questions on this lecture. So, my name is Rakesh Kanaganti. Welcome to our beautiful physics channel, Rakesh Sir Physics. Okay. So, what is the lecture going on? Units and measurements. Class number 3. This is the third lecture. In this lecture, we are going to discuss about a principle of homogeneity of dimensions. Principle of homogeneity of dimension. Principles of homogeneity of dimensions. So, listen the definition for principle of homogeneity of dimensions. Only the physical quantities, PQ means what? Physical quantities having the same dimension, the same dimensions can be added, subtracted, or can be equated. What is the definition of principles of homogeneity of dimensions? Only the physical quantities having the same dimensions. Dimensions means I told you in a yesterday's class, a previous class. So what is that? Dimensions are nothing but simply powers. Okay, dimensions are nothing but what? Simply powers. Only the physical quantities having the same dimensions or powers can be added, subtracted, or equated. That means if you are take one equation, if you are taken one equation, so whatever the physical quantities are having the same dimensions in that equation, so that quantities can be added, subtracted, or can be equated. So listen carefully and just you put this statement in your mind. So what is that? Quantities, the physical quantities having the same dimensions can be added, subtracted, or equated. Is this clear? Just keep in your mind. So I'm going to give one example. So if the given equation is like this, that is B is equals to A plus BT. V is equals to what? A plus BT. I'm taking a simple equation. Okay. Find out the dimensions of A and B. Find the dimensions of A and B where V tends to velocity and T tends to time. V tends to what? Velocity and T tends to time. What we have to find? We have to find the dimensions of A and B. Have a look. Given equation is what? Solution. B is equals to A plus BT. According to principle of homogeneity of dimensions, what is the definition says? The physical quantities having the same dimensions can be added, subtracted, or can be equated one dimensions. I'm just rewriting this equation as v. If a come to this side, it becomes minus a, and bt comes to this side, minus bt is equals to 0. Can I write like this? Okay. So what is this? V minus a minus bt is equals to 0. According to this definition, see, the physical quantities having the same dimensions can be added, subtracted, equated. Same dimensions added, subtracted, or equated. See, A is subtracted from B. A is subtracted from B. Subtracted. Why it is subtracted? Because the physical quantities V and A having the same dimensions. That means the dimensions of V and A are same. Because why? Because they are subtracted. Is it clear? Therefore, dimension of B is equals to dimension of A, because they are subtracted. Why they are subtracted? Because they are having the same dimensions. They are having the same dimensions. That's why I'm writing same dimensions. Dimension of V is equals to dimension of A. Is it clear? We have a previous year questions on this concept. Only two lines of definition. What is that? The physical quantities having the same dimensions can be added, subtracted, or can be equated. So if the dimension same, we can, in that equation, the physical quantities can be either added or subtracted or can be equated. Okay. So is it clear? Right. So what is the dimension of V? V is nothing but velocity. Velocity means distance by time. Distance is nothing but what? Dimensional symbol for distance, L, divided by t, distance by time. The rate of change of displacement or distance is called what? Velocity, is equals to dimension of A. So the dimensional formula of velocity, acceleration, okay, torque, momentum, work, all these things that we are discussed in a previous session. So such dimensional formula, class number 02 by Rakesh sir. In a search bar you will get that lecture, how to write the dimensional formulas. Is it clear? Right. So L by T is equals to what? Dimension of A. So what are the dimensions of A? So dimension of A is equals to no mass term present. So mass power 0. L is there. L power 1. If T comes to numerator, then T power minus 1. So this is what? Dimension of A. Now we have to find the dimension of B. How to find the dimension of B? So dimension of B is equals to, we have to find the dimension of B, we have to find. How can we find? See, the term bt is subtracted from V. The term bt is subtracted from V. Why bt is subtracted from V? Because subtracted. Why? Because they are having the same dimensions. They are having the same dimensions. Therefore, the dimension of the dimensions of the dimensions of velocity is equals to dimensions of bt. Dimensions of bt. Here bt is there. Okay. So what is the dimension of velocity? Distance by time. Distance by time. What is t? T is nothing but time. So dimension of b into, what is the dimension of time? Capital T. Is it clear? Right. If t comes to this side, it becomes L by t square is equals to dimension of b. So therefore, the dimensions of b is equals to what? L. Any m term is there? No mass term. M power 0. Okay. So L power 1. If t power 2 comes to numerator, it becomes t power minus 2. So what is the dimension of b? M power 0, L power 1, T power minus 2. Are you getting? Any doubts? So what is the principle of homogeneity says? Same dimensions. Whatever the physical quantities having the same dimensions can be added, subtracted, or equated. So this is the given equation. And just write this equation like this. So I'm bringing this A to this side and BT to this side. So plus A becomes minus A, plus BT becomes minus BT is equals to 0. Where A is subtracted from V. A is subtracted from V because they are subtracted. Subtracted means They are having the same dimensions. Just I'm equate those two. Dimension of P is equals to dimension of A because they are having the same dimensions. That's why we are subtracted. So come to here. So BT, the term BT is subtracted from V because they are having the same dimensions. So dimension of V is equals to what? Dimension of BT. So the dimension of T is what? Capital T, and the dimension of V is what? L by T. So if T comes to this side, it becomes L by T square. So the dimension of B is equals to what? M power 0, L power 1, T power minus 2. Is it clear? Any doubts? Pause the video and write the notes or take the screenshot. Your convenient. 3, 2, 1, go. Right? I hope that you understand how to write the dimensions of a constant. Let us see one more example. So this is a previous year question. Okay. So V is equals to AT plus B by T plus C, where V tends to velocity, T tends to time. V tends to velocity and T tends to time. Find the dimensions of A comma B and the C. Dimensions of A comma B and C. We have to find the dimensions of these constants. Pause the video and try the solution. 3, 2, 1, go. I'm going to do the solution. Have a look. What is the given equation? V is equals to AT plus B by T plus C. Okay. So what is the principle of homogeneity says? The physical quantities having the same dimensions can be added, subtracted or equated. The physical quantities having the same dimensions can be added, subtracted or equated. I'm just writing this equation as V minus, if AT comes to this side, it becomes V minus AT, and plus B comes to this side, minus B by T plus C is equals to 0. Are you getting? Right. So AT is subtracted from V. AT is subtracted from V. Why it is subtracted? If it is subtracted, then they have same dimensions. So dimension of V is equals to what? Dimension of AT. So dimension of V is equals to dimension of AT. Okay. What is the dimension of velocity? Displacement by time. What is the dimension of A? We don't know. We have to find. What is the dimension of T? Time is nothing but capital T. If T comes to this side, dimension of A. Dimension of A is equals to, if T comes to this side, it becomes T square, L by T square. So this is what dimension of A. It can also written as dimension of A is equals to, no mass term is there, mass power 0, L power 1. If T square comes to numerator, it becomes T power minus 2. Are you getting? Right. So next one. I want to find the dimension of B. So what is that? Dimension of B. So here B is there. Okay. So V minus AT minus B by T plus C. This B by T plus C is subtracted from V because V and B by T plus C having the same dimensions. So dimension of V is equals to dimension of B by T plus C. Are you getting? Right. What is the dimension of V? Dimension of V is nothing but distance by time. Okay. So we don't know the dimension of B. What is C? C is constant. Constant has no dimensional formula. One time term is there. What is the dimension of time? Capital T. Are you getting? So dimension of B by T plus C. Okay. So dimension of B divided by, what is the dimension of T plus C? T plus means what? T plus C means what? C is a constant. Constant does not having the dimensional formulas. Time term is there. What is the dimension for time? capital T. So bring this T to this side. So it is a denominator. If it comes to numerator, it makes multiply. So that is equals to what? Dimension of B. So TT get cancelled out. Then dimension of B is equals to what? L. Okay. Dimension of B is equals to what? Capital L. Right. So third one, we have to find the dimension of C. Right. How to find the dimension of C? If you observe this equation carefully, in a denominator, there is a term T plus C. Here we have what? T plus C. According to principle of homogeneity, what is that? The physical quantities having the same dimensions can be added. Same dimensions can be added. Same dimensions can be added. So here T is added to C. T is added to C. That means the dimension of T is equals to dimension of C. So therefore, the dimension of C is equals to what? Capital T. Dimension of small t. Time is what? Dimensional symbol for time. Capital T. So this is the dimension of C, and this is the dimension of B, and this is the dimension of A. Are you getting? So I hope that you learned how to write the dimensions of a constant. Is it clear? Any doubts? Right. So I'm taking one more example. So example number 3. Okay. So if the given equation is like this, P is equals to P naught e raised to minus alpha t. Find the dimensions of alpha where P and P naught are not defined. P and P naught are not defined. They are not given their values. Pause the video and try the answer. Try the solution for that question. Pause the video. 3, 2, 1. I'm going to solve the solution. Right. So what is the given equation? P is equals to P naught e raised to alpha t. Here P and P naught are not defined. That means we don't know the values of P and P naught. So only the term we have e raised to minus alpha t. E power minus alpha t. As we know, in our second lecture I told you that constants, exponentials and trigonometric terms does not have a dimensional formulas. So exponential has no dimensional formula. Exponential has no dimensional formula. Here alpha t is there. Okay. So now exponential has no dimensional formula, but we have one exponential power term. Okay. Na? So what is that? Alpha t. So the dimension of alpha t is equals to m power 0, l power 0, t power 0. So because exponential has no dimension, see n power 0, l power 0, t power 0. Is it clear? So alpha t is equals to what? No dimension. So dimension of alpha we have to find. What is the dimension of t? The dimensional symbol for time is what? Capital T is equals to m power 0, l power 0, t power 0. If t comes to this side, then dimension of alpha is equals to m power 0, l power 0, t power 0 divided by t. So multiplier, if it is come to this side, it makes division. If t comes to numerator, so dimension of alpha is equals to what? M power 0, l power 0, t comes to numerator, its power becomes minus 1. So this is what? Dimension of alpha. Are you getting? Right. So pause the video and write the notes. 3, 2, 1, go. Okay, right. Let us see one more example. So 1, 2, 3. This is a fourth one. With the given equation like this, t is equals to 2 pi into under root of ml cube by y 3y x. T is equals to 2 pi into under root of ml cube by 3 into yx. Okay. Find out dimensional formula of X, where m tends to mass, okay, so L tends to length, Y tends to Young's modulus, Y tends to what? Young's modulus, okay, so L tends to length, m tends to mass, Y tends to Young's modulus, capital T tends to time period. So what we have to find? We have to find the dimension of X. Pause the video and try the solution. 3, 2, 1, go. Right. I'm going to solve the solution. What we have to find? Dimension of X. Okay. So M means what? Mass. L means what? Length. Y means what? Young's modulus. And we have to find X. So the given equation is what? 2 is equals to 2 pi into under root of ml cube by 3 into y into x. Okay. So squaring on either side. Just square on either side. Okay, squaring on either side. What happened? T square is equals to 2 to the 4 pi square. If we made a square on both sides, then the root will be get cancelled out. We get a ml cube by 3yx. What we have to find? Dimension of x. So bring this x to this side. So t square into x is equals to 4 pi square by 3 into ml cube by y. Okay, so right, dimension of t square into x is equals to, so constants does not have dimensional formula. I'm writing dimensional formula for x because t square x is equated to ml cube by y. So the physical quantities are having the same dimension, can be equated. Here t square x and this term are equated because the dimensional formulas are same, right? So dimension of ml cube by y. Okay, so the dimension of t square is t square, and dimension of x we have to find. So that is equals to dimension of mass, capital M. Okay, so L cube, L is nothing but what? Length, that is capital L cube. Y, what is y? Young's modulus. What is Young's modulus? So Young's modulus is y, nothing but the ratio of stress by strain. The ratio of stress to strain is called what? Young's modulus. What is stress? Force upon area. What is force? Mass into acceleration divided by A. Okay, area. So mass, capital M. Area, sorry, acceleration, L by T square, L T power minus 2. Area, L square. L get cancelled out. If L comes to numerator, M power 1, L power minus 1, T power minus 2. This is what? Stress. What is strain? Strain is nothing but what? Change in length through its original length. The ratio of change in length to its original length is called what? Strain. So delta L, length, dimensional formula is L. Normal length, L, get cancelled out. Dimensional formula, M power 0, L power 0, T power 0. All these things that we are discussed in a lecture number 2. Okay. So what is the dimensional formula of Young's modulus right now? So Y is equals to stress by strain is equals to, what is that? Stress by strain is equals to stress m power 1, L power minus 1, T power minus 2 divided by strain has no dimension. That means only the dimensions of Young's modulus are what? M power 1, L power minus 1, T power minus 2. Are you getting? All these things we are discussed in a previous lecture. Okay. So go to search bar and search dimensional formula 0 2 by Rakesh sir. You will get all these things. Right. So capital mass, dimensional formula is capital M. Length, L cube is nothing but L cube. Y is what? Young's modulus. What is the dimensional formula of Young's modulus? M power 1, L power minus 1, T power minus 2. Okay. So M m get cancelled out. If L power minus 1 comes to numerator, so after this, so t square into dimension of x is equals to, okay, so get cancelled out, okay. So if L power minus comes to numerator, it becomes L power 1. Already L power 3 is there. L cube into L power 4. T power minus 2 is there. If it is comes to numerator, it becomes t square. Have a look. Here t square and t square get cancelled out. So finally, the dimension of x is equals to what? L to the power of 4. This is the answer. Are you getting any doubt? Pause the video and write the notes. 3, 2, 1, go. Okay, right. So let us see the next example. That is fifth example. So the given equation is like this. V is equals to alpha by beta 1 minus e raised to minus beta into t. 1 minus e raised to minus b, sorry, not beta, it is b into t, where v tends to velocity, t tends to time. Find out the dimensions of alpha by beta. Find the dimension of alpha by beta, alpha, beta, b, whatever it is. We have to find this. Are you getting? Pause the video and try the solution. 3, 2, 1. Right. I am going to solve the equation. So given equation is what? V is equals to alpha by beta into 1 minus e raised to minus beta into t, beta, b, whatever it is. It is a constant term. Okay. So one thing you should remember. What is that? The physical quantities are having the same dimensions can be added, subtracted, or equated. So the exponential, trigonometrical terms and constant terms does not having the dimensional formula. Okay, that's it. You will get the answer. Okay, right. Let us see. Here, an exponent. Before going to solve this, let us see this term. That is what? E raised to minus beta t. They are given. Okay. Exponential has no dimension. Exponential has no dimension. Okay. So when the exponential has no dimension, then this term becomes what? B into t. The dimension of b into t is equals to m power 0, L power 0, t power 0, because the exponential has no dimension. Then this power term becomes what? No dimension. M power 0, L power 0, t power 0. We have to find dimension of beta. We have to find dimension of beta. Dimension of beta. What is dimension of t? T is nothing but what? Time. Capital T is equals to m power 0, L power 0, t power 0. If t comes to this side, it divides m power 0, L power 0, t power 0. That means dimension of beta is equals to m power 0, L power 0, t power 0 divided by capital T. If it is comes to this side, it divides this term. Now this t comes to numerator. Then it becomes dimension of beta is equals to m power 0, L power 0. Here t power 0 is there. If capital T comes to numerator, it becomes t power minus 1. Base is same. Powers will be added. 0 minus 1 minus 1. T power minus 1. So this is the dimension of beta. What is that? M power 0, L power 0, t power minus 1. Or simply you can write t power minus 1. No problem. Okay. Right. Now what we have to find? We got dimension of beta. What is that? Dimension of beta is equals to what? T power minus 1. Now what we have to find? Dimension of alpha. Dimension of alpha we have to find. Okay, what is dimension of alpha? Again take this equation. V is equals to alpha by beta 1 minus e raised to alpha into, sorry, beta into t. What we have to remember? The physical quantities having the same dimensions can be added, subtracted, or can be equated. Right? They can be added, subtracted or equated. If you observe carefully, this term is what? Constant, and it has no dimension because it is constant term. Okay, v is equals to alpha by beta. Why they are equal? Their dimensional formula is same, so that's why, that means their dimensions are same, that's why we are equated these two. Are you getting? Therefore dimension of v is equals to dimension of alpha by beta, because they are having the same dimensions, that's why we are equated is equals to. Are you getting? Right. What is the dimensions of velocity? Distance by time, that is equals to, we have to find the dimension of alpha divided by, we already find that dimension of beta. What is dimension of beta? T power minus 1. T power minus 1. Are you getting? So dimension of alpha is equals to, if t power minus 1 is in a denominator, if it is comes to this side, it becomes L t power minus 1 divided by t. If t comes to numerator, it becomes what? L t power minus 1 already is there. If it is again comes to numerator, it becomes t power minus 1. Bases same, powers will be added. T power minus 1, t power minus 1, t power minus 2. Are you getting? So what is dimension of alpha? L t power minus 2. What he asking? Alpha divided by beta. So therefore alpha by beta is equals to, what is that? Dimension of alpha L t power minus 2 divided by dimension of beta t power minus 1. Alpha is L t power minus 2, beta is t power minus 1. Again t power minus 1 comes to numerator, it becomes L t power minus 3. So this is the answer for the dimensions of alpha by beta. Are you getting? Any doubt? Right. I hope that you understand this concept, and we will solve some more examples because this is an important concept. Okay, for MSET, JEE, or NEET. So any entrance examination. 2, 3, 1. Let's go. Right. Example number 6. So the given equation is like this: y is equals to a sin kx minus omega t. Y is equals to a sin kx minus omega t. Find the dimensions of k, omega and a. K, omega and a, where y tends to displacement, x tends to position or distance, t tends to time. T tends to what? Time. So find the dimensions of k, omega and a. Pause the video and try the solution. Okay, 3, 2, 1. Right. I'm going to solve the equation. The given equation is what? Y is equals to a sin kx minus omega t. Okay, right. So we have to find the dimension of omega k a. So sine of something they are given. Sine of, this is what? This is comes as a, this is taken as an angle sine theta. So sine function, cos function, exponential function, logarithmic function, all are having no dimensions. All are having no dimensions. So when there is no dimension, we can write our equations as sine of kx minus omega t has no dimension. So m power 0, L power 0, t power 0. So if you observe this term carefully, here kx given and here omega t is given. Kx and omega t. And see, and just write this equation as dimension of kx, where k is constant, x is what? Distance, and m power 0, l power 0, t power 0. Okay, so what we have to find? Dimension of k. Okay, so what is dimension of x? X is nothing but what? Position or distance. So the dimensional formula for that distance x is what? L, which is equals to m power 0, l power 0, t power 0. If L comes to this side, then dimension of k is equals to what? M power 0, L power 0, t power 0 divided by L. If L comes to numerator, so dimension of k is equals to m power 0, L comes to numerator, L power minus 1, t power 0. And simply we can write our dimension of k is equals to what? L power minus 1. Are you getting? So next term. So what is that? Dimension of omega t is equals to what? M power 0, L power 0, t power 0. Because the trigonometric functions has no dimension. What is t? Time. So the dimension of omega we have to find, and the dimension of t is what? Capital T is equals to m power 0, L power 0, t power 0. If t comes to this side, it becomes dimension of omega is equals to m power 0, L power 0, t power 0 divided by capital T. Again t comes to numerator, it becomes dimension of omega is equals to m power 0, L power 0, t power minus 1. Simply we can write dimension of omega is equals to t power minus 1. Are you getting? Same cinema repeated here. Okay, just here length term is there, just here time term is there. So what is the third one? We have to find dimension of a. So what is given equation? Y is equals to a sine kx minus omega t. Have a look. We have find the dimension of omega and k. So finally we have to find what? Dimension of a. Okay. So see, y is equals to a. Y is equals to a. So one thing you should remember, what is that? The physical quantities having the same dimensions can be added, subtracted or equated. Where y is equated to a. Y is equated with a. So that's why dimension of y is equals to dimension of a. So what is sine? It is trigonometric function. It has no dimension. So whatever the terms inside the sine, already we are find the dimension formulas for that. Okay, what is y? Y is displacement. So displacement, dimensional formula of displacement is what? L. So the dimension of A is equals to what? L. So this is the answer. So dimension of capital A is equals to L. Are you getting any doubts? Pause the video and write the solution. 3, 2, 1, go. Right. So, dear students, so these are some example problems I'm giving as a homework. So please do all these problems until you will get the answer. Okay. So practice these things. I hope you understood this concept. Okay. So what before going to do these problems, one thing, one definition you should remember in your mind. What is that? The physical quantities are having the same dimensions or powers can be added, subtracted or equated. So just keep it in your mind and try to solve these questions, important questions. Okay. So place your answer in a comment section. Okay, whether it is correct or not. Please try until you will get the answer. Okay. So this is a part 1 lecture on a principle of homogeneity of dimensions. Second part and the third part also is there, because from this concept we have the previous year question. So important concept. So listen carefully and practice all these things and comment your answers for these questions. Okay. So this is the end of the today's session, and the part 2 is loading. So stay tuned and practice all these things. I hope you are enjoyed this lecture, and this is Rakesh Kanayanti. Stay tuned. Jai Hind.